Dear learners, now after looking at a step 1 key performance indicators, let's move to the step 2, which is demand planning process. Now in step 1, we have seen that we do multiple data collection activities from different cross-functional departments. But in our step 2, what we do? We basically create statistical demand forecast based on the data that is received from multiple cross-functional teams. Like product management team gives us the phase-in and phase-out plans of the products. Then we collect system data for historical demand information. After we create all this demand information, and in step 2, we actually create the statistical forecast based on the data that we have. Once the statistical forecasts are created, we further take inputs from different cross-functional teams like sales, marketing, product management, and with their inputs, we do override our statistical forecasts. This override is done to make sure that our forecasts are more realistic to match the market situations. And this is our baseline that is created for demand planning numbers. Now, demand planning process is very vast and it is timely process. It needs lots of collaboration and coordination across departments, and it also needs lots of data. And because of that, this particular process has multiple KPIs to measure. So businesses may have a different KPIs looking at their business requirement, but we recommend that there must be 10 different key performance indicators that should be measured in this particular step. Now, we will also see these particular KPI measurements in Microsoft Excel with the real data in our next session. But before that, it is also important to understand the basic definition of each key performance indicator, which we will cover now. So let's start with our first KPI, which is forecast error. Now it is very simple that whenever we do any guess, and if there is any error that happens in the guess, for an example, if you are planning for an event where you feel that there will be 500 people who will come to the event. But in an actual, if more than 600 people arrive for this event, then what? So what happened here? Is your guess has gone wrong. And this is the error that is actually calculated in the first KPI, that is forecast error. And because of that, the formula for this particular KPI is nothing but that is equal to actual demand minus forecast. And what it tells us is the difference between actual demand and forecasted demand. Now let's take an example. If the demand or actual orders in the month of January 2022 were 100 quantity, but we had forecasted that there will be 106 quantity demand will be received for the January 2022 month, then there is a gap of the actual demand and the forecast that we have. So when we put these numbers in our example where the actual is nothing but 100, that was our actual demand, minus 106, which was our forecast. So what happens here is the forecast error that we receive is minus 6. Now for a better planning, it is always important to have a low forecast error in a business scenario. Now in this particular formula, there is major limitation that we do not understand the intensity of the error. So to understand it better, the forecast error here is minus 6, and that is coming out from the actual quantity of 100, which is our demand. But let's take another example. If we also forecast for another product whose demand actual quantity was 194 and our forecasted quantity was 1000, then again we will get the error which is minus 6. And here what we understand is even if we forecast for a higher quantity, the error is on lower side. But in our current situation, even we are only forecasting for 106 quantity demand, the error is still on minus 6. So the intensity here, it is on higher side because we are forecasting for a smaller quantity, but intensity is low in our another example of forecasting for 1000 quantity. I hope you're clear with this limitation. Now the next formula is absolute error. Now the word absolute is nothing but whenever you get negative error, this is actually converted into the positive numbers. And whenever you have positive error, that is actually kept as it is. So, the formula for absolute error is nothing but that is equal to absolute of actual demand minus forecast. And what it tells us is about absolute value of the forecast error. And it actually ignores whether the forecast error is in positive direction or negative direction. If we take same example and if we put our numbers in the formula, then our absolute error is nothing but +6, which is positive number. Again, this should also be on lower side as much as possible. The next particular indicator is squared error. Now the word squared in squared error itself talks about that error is squared. So the formula is nothing but that is equal to forecast error raised to 2 or forecast error into forecast error. That means error is multiplied by itself. Now when we put that in our formula, that means -6 raised to 2, which comes as 36. So our squared error is 36. Now what is benefit of squared error? So here we are taking only one of the particular product, and because of that, you will not be able to understand it easily. But in our next sessions, we will do the forecasting KPI calculation for multiple products, where you will be easily understanding what is the importance of squared error. So the one importance of squared error is it penalizes or it highlights the larger mistakes when we square the errors. And this actually overcomes the limitation of our first two formulas. And here, if we do squared error, which is 6 into 6, which equals to 36. Okay? Again, having a low squared error is always better for the business. The next particular indicator is root mean squared error. So again, the word root itself talks about it is nothing but the square root of mean squared error. And this is also one of the benefit of this particular formula is it highlights the higher mistakes and it penalizes those higher mistakes, and we can take right decisions to overcome those forecasting mistakes in a better way. Now since here we have taken only one product's example, you will only understand basic formula here, and you will understand how it differs in the real business scenario in our next sessions, where we will see same example for multiple products. So here, root mean squared error is nothing but square root of our mean squared error. So it is square root of 36. So our final outcome is 6 quantity. Again, the lower the RMSE value or root mean squared value, the better is the performance. Now let's move to the next formula, which is mean absolute error. Now what happens when we do forecasting for multiple products? This particular formula is very helpful to understand what is mean or what is average absolute error across the products that we forecasted. And the formula for this is nothing but that is equal to 1 upon n. N is nothing but basically number of products that we are forecasting. Into the bracket, sum of absolute of actual demand minus the forecast and bracket close. Now what this tells us, it tells us is all about average of the absolute differences between actual demand and forecasted demand over a time period for multiple products.
Now let's assume that there are two products, product A and product B, and we are forecasting for January 2022 month. And what we forecasted is 100 quantity will be the demand quantity for product A, and 115 will be the demand quantity for product B. But in an actual, when this demand is realized, we actually seen that customer ordered 106 quantity for product A against our forecast of 100, and customer ordered total 100 quantity demand for product B against the forecast of 115 quantity. Now, when we do total forecast, then total forecast is nothing but the sum of both, which is 215 quantity. And total demand is nothing but 206 quantity. And here, n is equal to 2, because we are forecasting for two different products. Now, when we put these particular numbers in our formula, then that is equal to 1 divided by 2, which is our n value, into the absolute of total demand. So total actual is nothing but 206 quantity, and total forecast was 250 quantity. And it tells us that mean absolute error is 4.5. So what this tells us is when we did the forecasting for two different products, on an average, the gap of the forecast error was 4.5 quantity throughout this particular forecasting exercise.
The next formula is mean absolute percentage error. We also call it as MAPE. And the formula for that is nothing but that is equal to bracket total of absolute actual demand minus total of forecast divided by actual and divided by n, and we will again close our entire particular formula here by giving another bracket and into 100% because we are calculating this particular error in percentage. And what it tells us is that our average forecast error in the percentage value. When we put all our data or assumptions in our forecasting formula, then what we get? We get mean absolute percent error of 2.2%. And having low error is always better for the businesses. Now, we do not recommend this formula to be measured, but since this is globally known formula, it is always important to keep this formula in your measurement and tracking. However, our recommendation will always stand for WMAPE. WMAPE is nothing but weighted mean absolute percentage error. Now, what is benefit in this particular formula is it looks at overall picture of all the products and then it does the calculation. But in normal MAPE formula, what it does is it basically averages the percentage of different errors, and in a mathematical context, when we average different percentages, it actually misleads the interpretation. But rather than doing average of different percentages, it is always better to calculate the metric based on the overall data or overall picture of the forecasting performance. And that's why when we see WMAPE formula here, you will notice the differences that we are not dividing by n value. And that's why it covers overall actual forecast and actual demand in the calculation. Now, when we put our numbers in WMAPE formula, then we get the WMAPE that is 4.4%. So you will have different values for MAPE and WMAPE formula, but the recommended value is always WMAPE. I know this is more technical, but we will still see how we can still simplify this with actual examples in our next session. So stay tuned for that. Right now, do not get confused. It is just understanding the formulas and their basic interpretation of different formulas.
The next formula is forecast accuracy percentage. Now it is very simple. Here, whatever weighted MAPE we have calculated, we are just deleting that error from 100% because 100% is the ceiling of forecast accuracy on higher side. So the formula is nothing but that is equal to 100% minus WMAPE percentage, and it tells us how close the forecast is to the actual demand. Now when we put these numbers here, the WMAPE value was 4.4%. And what we get here is 100% minus 4.4%. That means our forecast accuracy is 95.60%. The higher the forecast accuracy, the better is the business planning. The next is forecast bias percentage. Now what happens in our previous formula of forecast accuracy percentage, we do not understand whether we did over forecasting or under forecasting because the forecast accuracy is always in positive numbers. But the forecast bias tells us whether we did over forecasting or under forecasting. Now note that when forecast bias is minus or negative, then we did over forecasting. But when the forecast bias is positive, that means your demand or your market demand is positive, but we did under forecasting. So this is important term. We will see that in detail in our next sessions. Now the formula for forecast bias percentage is nothing but the bracket, then total of actual forecast divided by total of actual into 100%. When we put these numbers in our formula, we get that minus 4.4% is our forecast bias. Now since it is minus, it tells us that we did over forecasting. Now forecast bias should be always on lower side and it should be near to 0% to represent a better planning of the business. Now another important metric is forecast value add. Now you have already seen that in our demand planning process, we actually do two types of forecasting. The first forecast is a statistical forecast, which is basically coming out from the statistical methods. And second forecast is overriding that statistical forecast through the consensus of the cross-functional teams. So the first forecast is plain statistical forecast, and second forecast is overridden forecast based on the consensus inputs. Now, what happens in forecast value addition? We actually calculate how much value we have added when we are taking consensus inputs from the cross-functional teams. So the formula here is nothing, but that is equal to consensus forecast accuracy minus statistical forecast accuracy. And this tells us that whether it is improving or reducing our accuracy when we take inputs from the cross-functional teams over a statistical forecast. Now let's assume that our statistical forecast accuracy is 96%, but our consensus forecast accuracy is only 92%. So when we put the numbers in our formula, that means when our consensus forecast accuracy was 92%, but our statistical forecast accuracy was 96%. So it is giving minus 4% as forecast value add. Now when it is minus, that means the consensus is not adding value in the forecast accuracy improvement. Instead, it is reducing our forecast accuracy by the percentage that is represented in minus. But when this number is positive, it means the consensus is actually adding value in the forecast accuracy improvement. So the ideal situation is it should be positive in a business planning scenario. Now let's look at the forecast value add example in detail. For an example, this is our raw data. Okay, the first data talks about the statistical forecast for business laptop. And in the month of January 2022, we forecasted 960 quantity. In February, it was 1034 quantity. Then in March, it was 1345 quantity. But when we did a consensus forecast with the cross-functional teams, the cross-functional team suggested that we should reduce the forecast for this particular product in the month of January 2022. Again, in the month of February, they mentioned we should again reduce the forecast for this particular product to 981 quantity. And in March, they mentioned we should improve the forecast to 1450 quantity against our statistical input, that is 1345 quantity. Now when the actual demand is realized for Jan, Feb and March month, and when we saw what was ordered by customers, then let's assume for January month customers ordered 1000 quantity. Then for February month, customer ordered 1100 quantity, and for March month, customer ordered 1420 quantity. So when we calculate statistical forecast accuracy for the month of January, it is talking about 96% is the statistical forecast accuracy. But when we did consensus, the forecast accuracy is around 92% of the consensus inputs. And that's why the forecast value add is negative. That means even after consensus inputs, our forecast performance has not improved compared to statistical forecasts. So in summary, forecast value add may have positive and negative numbers over a time. But if you notice consistency in forecast value add number as negative value, then it is important that you should actually understand how better you can do consensus planning, or if it is not working, you should actually end to consider your statistical forecast for the future demand planning activities rather than consensus forecasts. Now in the month of March, if you see the forecast value add is 3%. That means the consensus inputs were helping to improve forecast performance. So this was all about forecast value add, and these are all the 10 different metrics we recommend for step 2. We will see all these metrics with a specific example in our next session. But now it is important to understand the formulas and their meaning and to get prepared for the next sessions. So thank you. Stay tuned for the next upcoming content.